In this video, we will learn how to estimate the area between the function and the x-axis. Okay, basically we are looking for the area here. Okay, which relate to something that we are going to learn in near future, the integration. Okay, okay. So one way to estimate the area is we could actually separate this into 5 rectangular shape, right? Like this. And then in this case, what we could do here is we could just finding this area right here, plus the area of this one, plus this one, plus this one, plus this one. Maybe I could call this one is A sub 0. This one is A sub 1. This is A sub 2, A sub 3, and A sub 4. Okay. So if we add the area A sub 0, A sub 1, sub 2, A sub 3, A sub 4, then we could actually estimate the area, okay, between the function and the x-axis then, okay. Okay, now this is the idea how we are going to work on this section now, okay. And now let's see how we could do it systematically then, okay. So in general, okay, if we want to find the area under the curve f of x with the interval between x equal to a and x equal to b, okay, here, we could actually choose a partition P of psi n, a choice of points that divide a and b into n subinterval of equal width, delta x is equal to b minus a over n. So in this case right here, we could actually separate this, make it delta x, okay? And then how do we find delta x? Basically is b minus a over n then. Okay. And the partition that we have is a equal to x naught, and then x of 1, x of 2, x of 3, up to x of n, okay? Where x of n equal to b. And now you will see that the subinterval that we are working with is x naught, x of 1, x of 1, x of 2, x of 2, x of 3, and so on and so forth, right? We have 3 ways to approximate the area by rectangles. And they are the nth left-hand endpoint approximations. We call it L sub n. The second one is the right-hand endpoint approximation, L sub n. And the last one is the midpoint approximation, M sub n. Okay. Now let's see how we work with the left-hand endpoints now. Okay. So then now you will see that here we separate this again. First we work with the x-axis, okay, and then we are going to separate this into n subinterval, okay. So and of course the width of each rectangle right here is the delta x. And then now, why we call this the left-hand endpoint? Because we choose the height of the rectangle, okay, from the left endpoint. The first one is a sub f of a, the height, right? So then in this case, you will see that the area of this rectangle right here, it will be f sub a delta x then. And then, of course, the next endpoint, it will be, because the width here is delta x, then it will be a plus delta x. And then to this number right here, it will be a plus 2 times delta x, right? And so on and so forth, okay? And of course, the second rectangle, you will see that the area of this one will be f of a plus delta x, okay? Because again, the input is a plus delta x here, times the width delta x then, okay? So if we do it n time, so we will have the L sub n, it will be f of x naught delta x plus f of x of 1 delta x plus up to f of x sub n minus 1 times delta x. which is this one right here. Okay. And of course, we know that x sub n minus 1, it will be a plus n minus 1 delta x then. Okay. Okay. Anyway, so if we do this way, then now think about this. What we could do here is we could, again, each term we have delta x, so we could factor the delta x, and then we just have f sub a plus f of a plus delta x plus up to f of a plus n minus 1 delta x. Then, of course, remember we learned the summation notation, right? We could rewrite this into the summation notation. Okay. Then we call this the left-hand Riemann sum, or the left-hand endpoints. Okay. Approximations. Okay, so let's see how we actually finding L sub 5. Okay. Now, again, remember L sub 5 meaning what? We separate this subinterval into 5 kind of like strip, right? Okay. So in this case right here, we could actually find out that the delta x is actually equal to 5 minus 0 over 5, which is equal to 1. Now again, why we have this one right here? Because in this case right here, we work with the interval is between 0 and 5. Okay. And then in this case right here, we notice that n is equal to 5. So this one is actually as n. Okay. And now, how do we find the area now? So L sub 5 basically is equal to, so then let's see. Now remember we work with the left endpoint, right? So basically we could actually draw it like this, then the second one, and the third one, the fourth, and the fifth. Okay. So then in this case, we could actually kind of make the notation like this one. Okay, so we have a naught plus a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. Okay? And then in this case right here, now if I want to work with the notations, then it will be what? A naught is f of 0 times delta x plus a sub 1, which is f of 1 times delta x. A sub 2 is f of 2 times delta x plus f of 3 times delta x plus f of 4 times delta x, isn't it? Okay, and then we know that f of 0 is equal to 3, and then delta x is 1. F of 1 is 3.5. F of 2 is 4. F of 3 is 1.5. And then f of 4 is 1. So basically, L sub 5 is 3 plus 3.5 plus 4 plus 1.5 plus 1. Okay. And then, of course, we know that the answer that we have is actually 13 then. Okay. Okay. Oh, there's one more thing that I would like to do here. If I want to rewrite this into summation notations, then it will be what? We are going to add the sum is I is from 0 to 4 of f of I times delta x then. Okay. Okay, so this is the idea about L sub 5. Then now, let us learn another one, which is the right-hand endpoints or right-hand Riemann sum then. Okay. So the right-hand Riemann sum is actually we are, instead of using the endpoint from the beginning, we work with this one. Okay, we work with the right hand endpoint now. So those are the endpoint that we have. Okay. So now, then let's see. So if I want to finding the out of 5, now again, to this one, my delta x is equal to 5 minus 0 over 5, because again, n is equal to 5, right? It's still 1. Okay. Then now, let's check this out. So we work with the right-hand endpoint, right? So we work with this number, okay, this height, okay. And then to this one will be this. Then to the next one, to this one, and the last one. Okay. And now, similarly, what we are going to do here is we would like to work on this problem. Okay. So let's see. So I have out of 5 is f sub 1 times delta x plus f2 delta x plus f3 plus f of 4 plus f of 5 times delta x. Okay, just like this. And then now if I want to again write in the summation notation, I could have this is I is from 1 to 5 f of I delta x. Okay, we could do this. Or remember, we could write like delta x times the summation, right? Okay, that is it. Okay. And then now, let's see. So basically what we could do is we could factor the delta x, which is easier. Okay, f of 1, f of 2 plus f of 3 plus f of 4 plus f of 5. Okay. We know that delta x is 1. Okay, then f of 1 is 3.5. F of 2 is 4. F of 3 is 1.5. F of 4 is 1. And f of 5 is 0.5. And then we find out that the answer is 10.5. Okay. Okay. So now you will see that this is actually is the idea about the right-hand Riemann sum now. Okay. Then the last one is actually how the midpoint. Okay. Now remember the midpoint basically is we are looking for the middle, okay, in between the a and maybe I could say that is x naught and x of 1. Okay, we are going to use this number, okay, to help us to find the height. Okay, so then this is the idea about the midpoint Riemann sum then. And of course, you could work with the notations. Okay, so it's a little bit complicated, but again, the idea, I hope that is a little bit easier to understand. That is, we are looking for the middle, right, between these two numbers. Okay, so let's see how we could use the midpoint Riemann sum to estimate the area now. Okay, so in this case, remember again, we are working with m sub 5, meaning the delta x is 1. Okay, this is my delta x. Okay. And then because we work with the midpoint, then now, in this case, we are going to use the 0.5 to help us to find the height now. Okay. So then in this case right here, okay, maybe we could actually work it like this. Okay. And then the next one, it will be 1.5, right? Then, okay, so maybe I should say that the x value that we are going to work with is 0.5 1.5, 2.5, 3.5, and 4.5, okay? To help us to work with the midpoint Riemann sum. So then we could have m sub 5 is delta x times f of 0.5, f of 1.5, f of 2.5, plus f of 3.5, plus f of 4.5. Okay, and again, delta x is 1. So you will see that f of 0.5 is about 3.2. Okay. And then f of 1.5 is about 3.9. F of 2.5 is 3.5. F of 2.5, right? And then f of 3.5 is here, slightly higher than 1. So how about 1.1? And then f of 4.5 is about 0.8. Okay. Then in this case, the sum of this number is 12.5. Okay. Yes. So this is actually is the idea how we actually work with the midpoint Riemann sum. Okay. Okay. So left endpoint, we are working the left end. Right endpoint, we work with the right endpoint, and the midpoint is the one in the middle, okay, between x naught and x of 1, something like this. And now, let's see how do we actually work with an example now, okay. Okay, so to number 4, we would like to approximate the area under each curve over the specific interval by using the indicate numbers of subinterval or rectangles, and evaluate the function at the left, right, midpoint of the subinterval. Okay. Okay, so then maybe let us look at this one first. Okay. So to this one, we would like to work with 4 subinterval. Okay, and then we work with the right endpoint. So what we are looking for is we are looking for the out of 4, right? This is what we are looking for. Okay. Okay. Then the first thing that we would like to do is maybe let us try to see what is my delta x then. So the interval is between x equal to 0 and 4. So my delta x will be 4 minus 0 over 4 then. Okay. Then in this case, it will be 1. 1 is my delta x. And then we would like to find out of 4, right? So this is what we are looking for. Okay. And then now, let's check it out. So if we have this is between 0 and 4, and then now we would like to separate this into 4 subintervals. Then, of course, the input that we are going to work with is 0, 1, 2, 3, and 4 now, right? No, actually, the input is 0, 1, 2, and 3. Okay, then now we are going to, we are working with the right, my bad. So it will be x equal to 1, 2, 3, and 4. Okay. So need to be careful then. Okay. Okay, then now the out of 4 basically is 1 times f of 1 plus f of 2 plus f of 3 plus f of 4. Okay. And then we know that f of x equal to negative 2x plus 9. So f of 1, negative 2 times 1 plus 9, which is 7. F of 2, negative 2 times 2 plus 9, which is 5. F of 3, -2 times 3 plus 9, which is 3. F of 4, -2 times 4 plus 9, which is 1, right? Then now we will have 7 plus 5 plus 3 plus 1, so which is 16. Oh, that's it. And now it's your turn. Now go ahead and try to see if you could work with B. Okay, so then let's see. First, again, I would like to find my delta x, which is between x equal to 2 and 3. So I have 3 minus 2 over 5. Then in this case, it will be 1 over 5. Then, okay, or maybe 0.2. Okay, so we are going to work with 2, 2, 3, and then we would like to separate this into 2, 3, 4, and 5. So it is 2.2, 2.3, 2.4, 2.6, and 2.8. And then remember, we would like to find the L sub 5. So if it is L sub 5, that means the input that we are going to work with, it will be 2, 2.2, 2.4, 2.6, and 2.8 then, right? Okay. And then now, let's see, how do we actually work it out the problem now? So my L sub 5 is the delta x is 0.2 times f of 2 plus f of 2.2 plus f of 2.4 plus f of 2.6 plus f of 2.8 then. Okay. Then what we need to do is we are going to use a calculator, right, to help us to finish the problem. Okay, so then it will be f of 2 is 6, f of 2.2 is 7.92, 10.08, 12.48, 15.12, okay, then it is equal to 10.32. Okay. And now, the last one is the one that we are going to work with the midpoint now. Okay, so we would like to find m sub 4. Okay. And then remember, in this case, my delta x is equal to 3 minus 1 over 4. So it's 2 over 4, which is 0.5 then. Okay, so to this one, let's see what is my input now. So I would like to have this is from 1 to 3. And then we separate this into 4 intervals. Okay, so if we separate into 4 intervals, it will be 1, 2, 3. Okay, it's 1.5, 2, 2.5, and 3. Okay. Now remember, we are going to work with the midpoint. Then the midpoint, that means the input that we are working with is the midpoint between 1 and 1.5, which is 1.25, then 1.75, 2.25, and then 2.75, right? Those are my input then. So then maybe let me write down that my input x is 1.25, 1.75, 2.25, and 2.75. Okay. Then my m sub 4 is delta x is 0.5 times f of 1.25 plus f of 1.75, f of 2.25 and f of 2.75. Okay, just like this. And of course, if we use your calculator, then you find out those numbers. And then we choose 16.625. Okay. Yeah. So then this is actually is the idea about the midpoint Riemann sum then. Okay, so then let us get to the next page now. Okay, so monotonic meaning increasing or decreasing functions. Monotonic function basically is the function is increasing or the function is decreasing. So if the function is increasing, if we work with the left endpoint, okay, then in this case right here, you will see that if the function is increasing, if we work with the left endpoint, then in this case right here, we actually we underestimate the result, right? If we work with the right endpoint, then it will be overestimate. So meaning what, the area under the curve is between L sub n and L sub n. Okay. So in this case, we call the L sub n the upper sum, and the L sub n will be the lower sum. Of course, on the other hand, if f is decreasing, then the area is in between L sub n and L sub n. Okay, so then think about this. How we could get closer to the exact area under the curve then? Okay. One way to do this is, what if we increase the n? Then if n is getting closer and closer to infinity, then of course, our estimate is getting better and better, right? So this is actually is the idea about the integration now. Okay, so something that we are going to learn in the next couple of weeks. Okay, is that if f of x is continuous on AB, then the endpoint and the midpoint approximations approach 1, and the same limit has n go to infinity. This means they are the same then. The limit n approaching to infinity of L sub n equal to the limit n approaching to infinity of L sub n equal to the limit n approaching to infinity of M sub n. Okay. Then if f of x is greater than or equal to 0, we define the area under the curve, under the graph over AB to be L then. Then this L is the area under the curve. So let's see if we could find the exact area, okay, by taking the limit of L sub n or L sub n or M sub n. Okay, so let us try this one then. The function that I have is f of x equal to 9x. So if I draw the function out, then we know that this is the function f of x equal to 9x. Okay. And then between 0 and 2, then in this case, what we are looking for, we're actually looking for this area. Okay. Now, of course, if we want to find this area right here, it's really easy, right? So it will be the base times the height is 2, then meaning this is 18 divided by 2. Then the area should be 18 then. Okay. So let's see if we could use the Riemann sum to get the same result now. Okay. Okay, so then how do we actually work it out? First of all, we start with delta x is 2 minus 0 over n, because we would like to make it n strip, right? So then the delta x is 2 over n. Okay. And then now we would like to work with the interval now. So in this case, let's see how do we actually work with the x of j. Okay. Let's see how do we actually work it out here. So then in this case right here, we have this is from 0 to 2. We would like to separate this into n strip. Okay. So then this will be 0 plus delta x, then 0 plus 2 times delta x, okay, and so on and so forth. So we would like to work with the endpoint, meaning what we would like to have this one is my r sub n. It will be delta x times f of 0 plus delta x plus f of 0 plus 2 times delta x. Okay. And then basically we have f of n times delta x. Okay. Okay. Then now let's see. Now remember in this case right here, we are going to work with the right endpoint. So let's see the formula here. We could using either this one or this one. Okay. Let's write this out. Oh, which is actually easier. Time the summation I is from 1 to n of f of I times delta x. Okay. Or delta x times summation I is from 1 to n of f of a plus I times delta x. Okay. Where a is 0. Okay. And so we will have delta x. We could actually go with the number now. 2 over n times the summation I is from 1 to n of f of I times 2 over n. Okay, this is better. Then now, what is f? F is 9x, right? So I will have 9 times 2i over n. Then remember to the summation 18 over n is a constant, so we could take this out. Okay. And okay, so then now remember from the last video, we know that the summation I is from 1 to n of I is n squared over 2 plus n over 2. Right? Okay, now this is what we are looking for then. Okay, and now we would like to find the area now. It will be the limit when n go to infinity of r sub n. So which is n go to infinity of 36 over n squared times n squared over 2 plus n over 2. So then it will be 36 over 2 plus 36n over 2. Oh, this would be 36 over 2n. Okay. And then now, of course, if we take the limit, then we know that this go to 0, right? So my answer will be 36 over 2, which is 18. Okay. Then you will see that we get the same answer in this case then. Okay. Okay, so now it is your turn, okay, to work on the example number 5. Okay, so to this one right here, we would like to find the area of x squared between 0 and 1. Okay, so what we are looking for is, we are looking for this area right here. Okay, so again, we work with the right endpoint. Okay, so then now, in this case, my delta x is 1 minus 0 over n, which is 1 over n. And then, in this case, I know that r sub n is delta x times the summations. I is from 1 to n of f of a plus I times delta x. Okay. Then in this case, I will have delta x. Delta x is 1 over n. Summation I is from 1 to n f of a. In this case, we know that this is a and then this is b, right? A equal to 0. So I will have 0 plus I times delta x is 1 over n. Okay, so let us simplify this. Okay, and now we have 1 over n, and then to this one right here, we have the summation I is from 1 to n of I over n to the square. Okay. So meaning I have I square over n square. Okay. And again, to the summations, 1 over n square is a constant, so we could take it out. Okay. Then now, let us try to work with this one now. Okay, again, from the last handout, the last video, we know that summation of I square is n to the cube over 3 plus n square over 2 plus n over 6. Then if we simplify this, so I have 1 over 3 plus 1 over 2n plus 1 over 6n squared. Then now, my L sub n okay, so the area is the limit n go to infinity of R sub n again, we know that this both go to 0, right? So my answer in this case is 1/3. Okay. So then now, how do we actually check the answer? Okay. The only way that you could check the answer is by using a calculator. Okay. So let me show you how do we actually use our calculator to find the area. Okay, so now let's turn on our calculator. Okay, so and then to this one right here, what we want to do is we click on y equal to, we need to input a function which is x squared. Right? Okay. And then now we are going to graph it. Usually I like to use a zoom and then number 6, the standard. So standard meaning from -10 to 10, and then the y minimum is -10 and y maximum is 10. Okay. And then how do we actually find the area underneath the curve, right? So we click on the second and trace to bring up the calculate, this menu right here. Then you will see that number 7, okay, is the integration, okay? So even though we haven't learned this yet, but again, this is actually something that we are going to learn in the future, okay? It's the integral of f of x dx. We choose number 7. Okay? And then the lower limit basically is your a value, okay? So which is 0, so we click on 0 and then put enter. The upper limit, which is the b value, okay? So our b value is 1, then we put enter, and that's it. You will see that here is our answer, which is 0.333, which is 1/3, right? This is exactly what we have. Okay. Okay, so that's it. So we know how do we actually using the taking the limit of the right endpoint, left endpoint, or the midpoint to help us to find the area under the curve then. Okay, okay, thank you.